Unless you've been living under a rock somewhere the past few years, you probably know that AI is all the rage across the tech industry. And that includes the storage industry. Here at NetApp, we have been doing a ton of work in the AI space, including partnerships with major technology providers such as NVIDIA and Cisco. Bobby Oomen and Dave Arnette dropped by for this Tech ONTAP podcast episode to tell us all about the latest work we have been a part of in the AI space.
Welcome to the Tech ONTAP podcast.
I love NetApp.
Oh, yeah.
I love NetApp because it's so fun.
I'm here in the video studio of the Tech ONTAP podcast, and I'm here with some special guests to talk to us all about SuperPod, AI, NVIDIA, all sorts of good things. To start us off, we have Bobby Oomen. So Bobby, what do you do here at NetApp and how do I reach you?
Hey, thanks again for having us, Justin. This is Bobby Oomen. My team is responsible for building FlexPod solutions, basically reference architectures working with our counterpart Cisco. And we've been doing this over 15 years. We're going to talk a little more in detail as we go.
Okay. Excellent. Dave Arnette is also here. Dave, how do we reach you and what do you do here at NetApp?
Well, you can reach me at arnette@netapp.com, just my last name at netapp.com. I'm a technical marketing engineer on the solutions team. I am focused on all things NVIDIA, SuperPod, NCP, which we'll get into, I'm sure, in a little bit here, and then working with Bobby to validate some of the other things that NetApp is doing with NVIDIA.
Okay, excellent. And, because we're on video, I can see that it's Dave's phone that's ringing. I can see him looking at his phone.
Yeah, that was my phone. The wife called at the most inopportune time, right?
That's all right. No big deal. All right, let's start off first by talking about NVIDIA SuperPod, what that is. Just an overview of the whole project, kind of the inception of it, how it got started.
SuperPod is a program NVIDIA's had around for a while. It's interesting and presents some unique challenges for NetApp because it is both a reference architecture for very large scale AI operations and HPC operations, really, but it's also a product that NVIDIA sells. And because it's a productized thing that they sell, they're very, very prescriptive about how it's configured, and they're very selective about who gets to participate and what the requirements are and things like that, right? So NetApp has been working with NVIDIA for, I've been working with them for 7 years now. And we had started out with things like what they called BasePod and our AI pod design, which is something that's still pretty valuable to customers who are looking to build things at a smaller scale. But in terms of industry standards and recognitions, SuperPod has become the gold standard, at least from a reference architecture perspective, for how to build basically AI factories, right? Very, very large infrastructures that can either do very large scale LLM training or very diverse workloads. There's a lot of other customers doing things that aren't LLM, believe it or not. And there's a lot of need still for very large scale operations for the enterprises that are building their business on developing new models and bringing technologies to market.
So what makes a SuperPod super?
Well, there's basically three key ingredients. It's the NVIDIA DGX servers. These are their purpose-built AI workhorses. They're always pushing the limits, both from the east-west perspective with InfiniBand and now introducing Spectrum-X, as well as for storage north-south traffic and user data in and out of the system. And then the final piece of that is a certified storage system. And that's where NetApp has really stepped up. And we have a great solution now that far exceeds most of the requirements for the performance evaluation for SuperPod, and then delivers a ton of value around data management to solve a lot of challenges, right? AI is not just a performance problem. It's more of a data problem, and the data management tools that we can offer and bring into a SuperPod really take it to the next level.
To touch on that, what sort of data management tools benefit AI workloads the most?
Certain SnapMirror and Flex Cache, right? Things where we can position data closer to GPUs or move them from remote locations in an effective way. We have a lot of customers working in the cloud and vice versa. And so being able to use these native data management tools can really ease a workflow instead of users having to make a lot of manual copies.
What about things like FlexClone? Does that play in here at all?
Well, FlexCones can be very handy for development purposes, right? Like AI development is a software development process, just like any other software development process. And using FlexClones allows development workspaces to be shared instantly. It allows for things like version control of both code and data in a typical CI/CD pipeline. All the same value of snapshots and clones in a traditional software development pipeline bring a lot of value to an AI development pipeline.
Okay. So this is a SuperPod, and we also have FlexPods. What's the difference between a FlexPod and a SuperPod?
The key difference is going to be the server system. And we have a long history of FlexPod, and that's where Bobby's in. But that's where NVIDIA really draws that line on SuperPod, is their server system.
To add on top of what Dave was saying, in the beginning, I said, we've been doing this over 15 years, and FlexPod is primarily intended as a converged infrastructure, right? So we put the networking and the compute from Cisco and the data management layer from NetApp to build an engineered infrastructure. We've been doing almost all of the workloads, and we are slowly adding AI to it. Now, what Dave has been talking about SuperPod, it's primarily training workloads. What we started with FlexPod is inference workloads, because the days of training, I'm not saying that it's over, but if you look at that curve, slowly the inference workloads is ramping up, right? So that's where we are pushing from a FlexPod perspective. You look at a bunch of solutions which came out already, it's all inference. And of course, we are looking at some of the training workloads using the HGX solution from NVIDIA. Instead of using a DGX box, what Dave was using for his SuperPod, we are using a HGX configuration from NVIDIA, still 8-way GPUs with NVLinks, and we would use Cisco Nexus switches with Silicon One configuration eventually, and obviously the data management layer, which is same, right, the common denominator. And that is what we are focusing as we churn out a FlexPod solution. So we have a bunch of RAG and Gen AI solutions, all of them. We were focusing the data management layer piece, as you were asking earlier, Justin. What are we doing? Are we using FlexClone? Are we using some of the features like the NetApp Trident, where data scientists would be able to spin up dynamically the volumes so that you still show the value of data management layer? Our goal is to give an infrastructure where customers would be able to add any AI workloads to an existing workload. For example, the X series solution, what we have with FlexPod, what it does is, instead of adding a new complete infrastructure, all I have to do is add a PCIe node with GPUs into that chassis. And I start my AI journey, which would be talking to the same data management layer along with a bunch of other workloads. And again, do you want to go for that purpose-built AI? That's when the HGX solution comes in, which looks for pure AI workloads. It's all about flexibility and giving customers the options.
So you said the end of training. I know you didn't mean like this is the end of it all, but it's moving more towards inference. So I'd like to understand the difference between training and inference and why there's a shift.
Well, the challenge that we see with a lot of enterprises is that training takes a lot of resources. And let's clarify something else. We generally are talking about large language models these days. There are still lots of other kinds of AI out there, but pretty much the only thing anybody's talking about is large language models, right? So training a large language model requires basically a data center's worth of hardware. And most companies can't afford to buy that for themselves, certainly. Some are looking at renting it. That's a part of the NCP program that I have been working with as well. But at the end of the day, it's not really cost effective for most businesses to try and train a model. On the other hand, it is super easy and cost effective to deploy a pre-trained model that was trained by somebody else, or link to an API on one of the openly public model services that includes some of the customization features that you can do with those. That makes a lot more sense for most businesses in terms of integration and deployment. And it's really where a lot of businesses are going to see the benefits of these things in their back office operations when individuals working in any role can basically ask a question about what's the right way to get something done and get a good answer and be able to move processes along a lot more effectively.
To add to what Dave said is, to me, if I have a large infrastructure which is doing probably just Gen AI or inference, that infrastructure is a candidate where I would be doing some of my fine tuning. And again, as we were saying, the data management layer, it's so adaptive, right? I should be able to run my training workloads, some of my fine tuning, and the inference. So recently, the team that includes Dave, myself, Mike Oglesby, and a bunch of others, we were looking at KV cache, extending that GPU memory to our storage layer because we know we have the capability to extend that cache from the compute perspective and do that scientific calculation along with the storage capability, what we are giving, the IO capability. What I meant is the inference, the ratio is changing from training to inference, right? More and more customers are doing inference, but the infrastructure, when we give, it will have the capability to do some of the fine tunings. You do inference all day and training in the night. So that's the infrastructure what we are giving.
So would you say that inference is more of like a training light? It's not the full training of the data set. It's like taking bits and pieces here and there based on your data's needs?
That would be more like fine tuning, right? There's a couple of phases of the life cycle of the model. The pre-training is really that heavy lifting AI factory thing I was talking about. Fine tuning is when you may take an existing model and do some additional training. Maybe you're only modifying a few layers in the neural network. Maybe you're using your specific data, things like that. What I like to say is inferencing is where you're actually interacting with AI, right? Inferencing is where you have created a model. There is no further development of that model, but it is presented in some way for users to interact with. That's where we're thinking about ChatGPT, where it looks like a search bar on any old web browser. But when you put information in there, what you're actually doing is feeding it into that model. And the inferencing takes the input that it is expecting to receive, works its way through the neural network in order to generate the output that's been asked of it. Okay. And inferencing applies to LLMs and every other model that's out there too, right? Any self-driving car is doing a lot of inferencing by looking at video and saying, okay, the road's clear, we can keep moving forward and so on. The LLM use case is just a little different because now you're directly interacting with it. You're asking questions in natural language and getting answers based on potentially some very specific thing if you've integrated a RAG pipeline or pre-trained accordingly.
So it's like the thinking part of the model.
Right. It's where the AI is actually being intelligent. It's returning the intelligence.
And the training is more of just rote memorization.
Effectively, right? The example I always like to use is, back in the early days when we were talking about image classification all the time, that's where you teach it what a cat looks like and what a dog looks like. And then the inference phase is where you start showing it pictures and saying, is this a cat? Is this a dog? It analyzes based on what it has learned and then returns an answer accordingly. Another good use case for inferencing is your bank or your mortgage lender. They can give you a mortgage approval in seconds, and that's basically an inferencing task. You provide some inputs, they look at those, and the model spits out, yes, that's a good risk, or no, that's not a good risk. And it's a super easy transaction from them for generating new business just by simply being able to say, hey, you're approved right now.
Yeah, to me, it's a way of semantic building of data points, and you use that to do the inference, as Dave was saying. Now you have a prompt rather than we calling it a training.
Okay. Have you seen Silicon Valley? Have you watched that show at all?
I have seen only a few episodes of it. It's pretty funny, but I didn't get too deep into it. You should
revisit it because there's an AI aspect to it, and one of the characters builds an AI model or an inference training of hot dog or not hot dog.
Oh. I used to joke when I started out and working on AI, people would say, hey, how's it going over there in AI? Are you really busy? I would say, no, I trained a model that reproduces my work with 96% accuracy, and I just sit back and let it do its thing.
Hey, well, there you go. Don't let anybody else hear that.
Yeah, I mean, that's become the norm now with ChatGPT. Now we're just going to give it some information and say, do my report for me.
Yes. DL, do my job is what they used to call it. but now the AI does your job for you.
Right.
That's right.
So you mentioned earlier you're working on something called NCP. So what is that, Dave? Tell me a little bit more about
The NVIDIA Cloud Partner Program is NVIDIA's program for working with basically customers who are going to or are currently offering basically GPU as a service, AI as a service, AI training platform as a service, any combination thereof, right? So we're talking about companies like CoreWeave or Lambda Labs. There's plenty of other more traditional service providers. We're not really talking about the hyperscalers. They basically are doing their own thing. They consume a lot of NVIDIA GPUs, but they build their own architecture around how they want to deploy those. Right. The NVIDIA Cloud Partner Program is another reference architecture program for the other kind of neo cloud providers on best practices on how to deploy these GPUs at massive, massive scale. And I'm talking thousands and tens of thousands of GPUs potentially training as a single environment or being used as a single environment. But what makes the NCP environment fairly special is that, well, one, it's based on either NVIDIA HGX servers or the NVL72s. The HGX would be OEM branded servers with the NVIDIA GPU boards, giving a service provider flexibility to work with their server vendor of choice in deploying this. And then a little more flexibility around the networking with the intention of supporting lots of multi-tenant users. This is where, again, a lot of other NetApp capabilities really raise the bar on what's possible, because these people are interested in multi-tenancy with quality of service and isolation of customers via network resources and so on. And these are all things that are right in NetApp's wheelhouse. We've been delivering these capabilities for traditional service providers for a long time. And now that we've demonstrated the ability to support the performance levels required by these massive numbers of GPUs, we have a really great opportunity to bring a lot of these capabilities into that cloud partner program.
So would you say that you're standing up NetApp systems in their data centers and they're presenting them as basically as a service storage for these?
Correct. That's the end result, right? These are services that are being offered by somebody where the end user may not actually know what's under the covers, but the service provider is looking for best of breed solutions to either meet specific things that services that they're trying to offer, or to deliver services in the most cost-effective and value-oriented way.
Now, are these presented more as your 1P service offerings where you just stand up a volume, or is it more like the Cloud Volumes ONTAP where you have your own managed instance of ONTAP that you deal with?
These wouldn't even really be like 1P. This would end up being more part of a service offering from those providers where you get 5,000 GPUs and 2 petabytes worth of storage capacity. And
it just basically comes as part of the package.
And it's just a part of the package, right? The goal of these providers is to really make consumption of these kinds of resources as painless as possible for the customers. We've already talked about how they don't want to build it for themselves because that's way too expensive. So they're trying to find newer and better ways to make these resources available to the end customers, and simplicity is at the top of the list. Now, we are absolutely taking advantage of things like the data management tools we've already talked about. We have a lot of interest from existing NetApp customers who would like to use these new cloud providers to do some of these things and are asking when we're going to get NetApp in there so that they can replicate directly to a NetApp system. So we're actively engaged with a number of these guys to start driving those conversations and get in the door there.
Yeah, I'd imagine there's a lot less friction when you want to, say, do a snap mirror from your on-prem system to these cloud providers, and you'd get from, say, a 1P provider where that has to kind of be built into the whole stack before they can offer it.
Yeah, 100%. One of the biggest challenges we have with those operations is not the NetApp technology. It's simple things like networking between the NetApp systems. These smaller providers have a lot more flexibility about how they connect with their end customers and the way they can get connectivity like that. So it's a little easier proposition to offer those kinds of services when there's not the other restrictions around the unified networking stack.
And I would imagine that security features like encryption and over-the-wire encryption and anti-ransomware comes into play even more with this type of scenario, because customers are probably a little nervous about moving it into a cloud situation they want to make sure that their data stays protected.
Yeah, and like I said, this is where a lot of newer NetApp features and some of our existing features really fit the bill. And to your point, we've had some specific interest in the notion that a service provider can maintain an encryption key for the entire storage system, and end customers can maintain a separate encryption key for their own volumes. That's the ultimate in multi-tenancy security, and there's pretty much nobody else out there who can do it like that right now.
You don't have to rely on the service provider saying, hey, we're good enough. Right.
The service provider is protecting the infrastructure and making sure that there's no physical way infrastructure can cause a data breach or anything. And then the end customer is allowed to go another step further to make sure that their data is protected in a way that only they can access it.
Okay. So that makes sense. The NCP being a cloud offering, so you don't have to buy a bunch of GPU. Because honestly, a lot of these training models, once they're done training, they don't need it anymore, essentially.
The high-end GPUs are really focused on training. They can do a massive amount of inferencing. And you'll hear Jensen at NVIDIA talk about how if you buy one of these for inferencing, and now that we're getting into model sizes that are as big as they are, it starts to become a little more true. But the notion that you can buy one of these high-end server systems and it'll save you money on inferencing costs is actually valid, because now you've got a server system that can handle multiple instances of very large models rather than having lots and lots and lots of smaller servers in order to handle the same workload. But at the end of the day, it is kind of overkill for a lot of tasks, and that's why there's a lot of interest in renting it. You can rent what you need, do the fine tuning you want to do, or do some custom training of something, and then hand those resources back. You're not paying for the downtime. What we have seen is that it takes a very high level of maturity in an organization in order to be able to utilize those kinds of resources effectively, constantly when they're on premise. So there's a lot of value for customers in renting these kind of things from the clouds. They will reach a certain point where they realize, you know what, if we owned a few of these servers, it would be cheaper, because now that we know what we're doing with it, we know how to run it, we know how to keep it busy 24 hours a day. But certainly until then, it gives a lot of people the opportunity to have the tools they need without having to make massive commitments in capital expense.
So Dave, this NCP, is it purely training, fine tuning, or I can do inference too?
No, it's intended to be inferencing as well. I was going to say, this is where some of these NCPs are offering LLM services as a service. There's all kinds of inferencing going on, whether it's individual customers using their own models and doing inferencing because it's a place they can get the big hardware and run these large models, or whether it's the service providers themselves offering models as a service or what have you. The NCP environment was intended to serve everything, basically what you would expect out of any other cloud provider.
Yeah, so along with those security features they were talking about the adaptability, the quality of service, or QoS at the storage level. I could do training, I could do inference, or any other workloads, any kind of workloads, especially from an AI perspective. A bunch of options are there.
Yeah, I like to say at this point, the inferencing and the deployment of models is really just like any other application workload. There are some unique requirements in terms of the GPU, but the way organizations are now looking at managing these things, it really is just another application. It's another microservice where there's an API call. You can have one application make that API. You can have a dozen applications make that API call. It still gets managed within a data center infrastructure. Kubernetes is extremely popular now because you can deploy pods of LLM instances and they're appropriately managed for the users that are interacting with them. And Bobby said before, and I agree, that inference really is the main thing that businesses are focusing on. You can use a lot of these models in an open manner where you just pay by the interaction, by the token, or you can download an open source model and host it on your own server and not pay by the token, but then you're responsible for maintaining it and such. So there's a lot of the same kind of cloud usage considerations here. People are paying for the convenience of just letting somebody else do it till they realize that it's more cost effective now that we know how to do it for ourselves.
As you break this down, it seems like there are features that are very valuable to service providers that might not be valuable to customers. And then there's features that are valuable to customers that might not be as valuable to service providers. And there's definitely a delineation there where a service provider will benefit from QoS, where a customer might not see that level. That's going to be controlled by the service provider itself. And then that becomes a charge mechanism for the service provider with QoS.
Another thing is the scalability. That's when Dave and myself, we were talking about the ERA, or the Enterprise Reference Architecture, right? That is something we built for NVIDIA because NVIDIA is making that as a mandate with all of the storage vendors who are certified with them. So the goal is, as they call it, scale units, for compute is a scale units for them. As they add scale units, as they scale it up, they wanted to make sure that from a storage perspective, are we able to deliver it? So Dave was talking about training. This is purely inference, where we got certified recently. NetApp is one of the very few storage vendors who are certified. Again, it's the ability to give a fully scalable environment so that customers could create that large GPU farm to do the inference, but at the same time, you have a data management layer which can handle security, which can handle the KV caches or the vector sets you create, or even a relational database management system running on it. When I talk from an agentic AI perspective, it can talk to some databases or file services, bring the information and bring it back to the prompt, right? Again, it's all about giving that answers in that latency, what customers are looking for, or the SLA the customers are looking for. End of the day, it's all about the data management layer. And that's personally, I would say same thing from Dave's perspective. That's what we wanted to focus.
So Dave, the NCP offering, is that already something that's available today with some of these providers, or is that something that you're just working on getting going?
Well, we just recently got certified in that program, so we don't currently have any offerings out in the market yet, but we are engaged in conversations with almost all of the players in that space and a few others that I wasn't really expecting. But like I said, there's other more traditional service providers like telecoms and such that maybe they're not interested in offering the range or scale of services that the ones focused on AI are, but they are still very interested in having this in their catalog and making it available even just to internal users.
Okay. And how would I figure out if something's available? Is there a way to kind of watch the space, or do I just have to keep checking back?
Well, we're getting a lot better about making announcements for things that we're getting published. I will say right now, we're certified for both the HGX NCP and the NVL72. This is the Grace Blackwell servers. We actually got some of the Grace super chips. So I've got some of the servers with the ARM processors in the lab, and we did a lot of testing. Of course, this is almost a no-brainer for NetApp because we don't have any custom clients or software that needs to run and would need to support a different kernel architecture and so on. So it was super easy just to install the ARM version of Ubuntu on these servers and hook them up and drive them to basically wire speed bandwidth on the high performance networking. So we've done the testing around that. Our certification for SuperPod with Grace Blackwell is still pending. They have some slightly different requirements that we're still working through. But with the NCP program, we've demonstrated that the performance is equivalent regardless of the server architecture, and they're on board with whatever opportunities we can work with them on.
And these performance numbers are all driven through NFS over RDMA, is that right?
That's correct. All of our testing now is built on NFS over RDMA with parallel NFS and with session trunking to achieve maximum throughput and bandwidth on the storage system. The other result of this is that, of course, we have to support NVIDIA GPU Direct Storage, which is an RDMA transfer directly from the GPU memory into a storage space. And we actually saw a good use case of this. Our colleague Mike Oglesby published a blog regarding the LLM KV cache that leverages GPU Direct Storage. This really makes for a high performance solution where the GPU can offload some of the cache it's storing and ultimately keep a much larger cache, but still access that at a very low latency, high bandwidth manner when necessary.
Yeah, it's also useful because with NVIDIA GPU, you can't really grow the RAM easily, right? But with a KV cache that's hosted on NFS, you can grow and shrink that all you need.
Yeah, you can grow and shrink it very easily, and you can share it, right? There's more things in the works. One of the challenges with working in this space is that there are changes and new developments weekly. And the notion of spreading things across more GPUs starts to bring a lot of value to a solution like what we're offering.
Yeah, if they're all working off the same data sets, it doesn't make sense to have individual caches for every one of them.
100%, yeah.
Yep. So, Bobby, I know that you're working on some Cisco stuff. What sort of things do you have in the works here?
So we just concluded a Cisco Live, which is the Cisco trade show. So when Cisco does their trade shows, I usually say we go and invade the network, right? So what we do is, instead of using the convention center network or any of the access points for that matter, we go and use Cisco switches access points. And what happens under the covers is you need a data center to store all these information. You need some management VMs. That's when NetApp FlexPod comes into picture, where we have a FlexPod with Metro cluster setup. So we've been doing this for the past 11 years. We do have in US, where we keep the system in the San Jose Cisco data center and bring it to the show floors, whether it's in Las Vegas or this time it was in San Diego. And we have the same thing in Amsterdam. So what we did, this is the exact same thing I was talking about earlier, Justin, as last year we upgraded to X Series, their latest compute system. This year we wanted to do AI. We wanted to introduce a solution, what we did for FlexPod AI, right? So what we did is we added a GPU node to the same chassis with a bunch of GPUs, L40S in this case, and a RAG application or a prompt or a chatbot where customers or attendees who are coming there could ask questions. I have a saying that if I have answered a question once, I shouldn't be answering that question again. So what we did is we put this chatbot up and running, which is basically an iPad right in front of this data center. Customers or attendees could come and ask questions. So at the end of the fourth day, we had around 150 questions. So the way I was saying my same lines everywhere is, if, so for example, 3 questions were asked by a person, that's 50 people got their questions answered without our help. Our goal at that time to show was, yes, that is a FlexPod Metro cluster setup, have hundreds of VMs running from an event perspective. Now I have an AI chatbot or an AI application running on top of it. They did data management layer, which gives the data consistency and integrity. And at the same time, it's, for me, resiliency is not an option. 22,000 attendees coming, right from the registration till you conclude the show, all the sessions which is going on, everything is passing through that network, which is backed by NetApp Metro Cluster or a FlexPod solution. Now we have AR running. Now, as I was saying earlier, our goal is to show something and next year take it to the next level. Maybe get the live data for maybe the syslogs of the switches and process it and give a meaningful insights to the customers or the attendees who are coming there so that the information is at the fingertip. And we wanted to show that it is on a most secured data management layer in the planet.
Do you ever get people asking really dumb questions on those things? You got to get that. It's the tech industry. I mean, immature questions like,
yes,
like, how big is my butt or something? And then does the AI react accordingly? Does it say that question? No, stop. Just stop.
Yeah.
You mentioned Cisco Live and that you were working on this particular project and you've been doing it for a while. What does that translate into for future endeavors? What are you putting that into work for future conferences, future white papers, that sort of thing?
I was chatting with my Cisco team earlier today. Our goal was, hey, we are doing all this, or I say the life of a FlexPod engineer, right? They spend sometimes 3 months to churn up a CVD or the Cisco validated design. It is a testimony for sure as we publish all these solutions, but it makes more sense if we could implement these solutions on a live show like this. I couldn't find a better place than Cisco Live, obviously, to show the implementation of this solution. And Cisco basically go and do this. To me, it's an opportunity for us, especially for the FlexPod team, to show what we do here from a NetApp perspective, not just a FlexPod team perspective, Events like Cisco Live is the best example where we are showing the real value of data management layer.
Yeah, Cisco has a saying where the show is the demo. They make a big deal about the fact that they bring a brand new network in, they set it up in the course of a week or two, and they deliver a world-class experience every time. And that is one of the most powerful demos that you could offer to a customer. And being a part of the NetApp team that gets to show those same kind of things, I did actually serve in that capacity a few years ago myself. So I've had that experience as well. And it's really a powerful thing for NetApp to be talking to customers. We've even had incidents where there was an outage and we relied on the data protection technologies like Metro Cluster that we use. And the show keeps running and nobody ever knows. It's really remarkable to see the things that we do in action and functional and saving the day on a regular basis.
Yes, as Dave was saying, we call it the network is the demo. This happened in Amsterdam. One of the electricians went and powered up the wrong switch. That brought down the primary side. So what happens with Metro Cluster? Transparently, things get scaled over to the second side. It's separated by close to a kilometer. Now, as I was saying, resiliency is not an option for us. We wanted to make sure that the Wi-Fi's which are used by the attendees who are coming there is still up and running and was able to serve the data. We have an opportunity where we could show the true value of data management layer.
Yeah, it's unfortunate, though, that you can't really tell the failover capabilities because you don't really want to publicize the outage, right?
You don't want to let anybody know there was an outage. You just, not until after it's long over, right?
You just want to brag about it.
By the way, you didn't notice the complete failure of the data center, did you?
Yeah, wait for that guy that powered down the switch to get out of the building, give him cover.
Right.
All right, cool. So I expect that you'll be doing similar things for Insight coming up. Is that accurate?
Yeah, there's a lot of discussion. We're still working through the details of exactly what we're going to demo and how we're going to go about doing that. But there's definitely a lot of excitement about getting the opportunity to really show off some of these things at Insight.
There are a bunch of things coming from FlexPod aspect as well, from a data management layer, or NetApp as a data management company. We have a lot we can do with AI. There used to be a time we always say IOPS, right? Input output per second. When it comes to the data DSS or the warehouse, we say throughput. Now the data scientists are talking tokens. But I say we don't care whatever it is. Our data management layer is same. Yes, KV cache, we could do it. Vector set, we could do it. Traditional databases, we could do it. Private data lake, we could do it. Nothing changes. End of the day, it's about data consistency and data integrity. That's what we can give.
Would you say that a token is basically an IOP or a session?
Kind of, I would say a token is around a 3/4 of a word. So if I kind of really query it, you and me, we kind of drill down into the storage. Yeah, it could be an AK block.
I like to think a token is the IOP on the front end of the LLM. It doesn't directly amount to an IOP at the storage layer, but it's how the LLM thinks in terms of the chunks of data. So you present it with some information, it chunks that up into tokens, and then it processes it. Then it pulls out a whole bunch of tokens and reassembles them into an answer. And it's kind of the unit of input and output that the LLM uses on the front end. And then that just ties down into regular apps on the storage array.
Yeah. I just figured that having a translation for that would be good for storage.
Yeah, that's something one of the guys on my team is exploring, is if we can actually make some kind of performance metric in the context of tokens that makes sense. How many tokens per second, or how many instances at a token rate, or something like that. There is not currently an industry standard for correlating LLM performance at the token level to storage performance. But that's definitely something we're looking into because, like Bobby said, performance is a big part of this equation, but it's not the only part. Once you've reached that, performance is table stakes. If you're not fast enough, you don't even get to play at all. So once you're in the game, it becomes more about what are the other things you can do and how can you make maximum efficiency with performance and do other things. And we're definitely looking at how to put that into the context of the LLM operations so that the end users can make more educated assessments of what they're getting or what they're looking for.
Yeah, so both Dave and myself, we were at GTC, the NVIDIA conference. We heard about two things, KV Cache and AI Factory. And to me, the common denominator is data management layer, whether it's tokens or having the ability to do the data protection or having the ability to create copies of clones of the data. I shouldn't be say copying. We have that capability. Again, latency is something which is part of the fundamental building block to even stay in that equation.
I mean, if there's no standard for tokens, just make one up.
Yeah. True.
Well, and they're different on a per model basis, right? Some models make larger tokens, some models make smaller tokens, and there's no standard for any of that yet, let alone how to correlate that to a storage IOP.
Yeah, I've seen competitors throw out, oh, we do a number of tokens per second. I'm like, how do you know?
Well, how do you know that's relevant in any way? It's easy enough to say we do a X number of tokens per second. What is that, 100 megabytes a second at the storage layer? There's really no way to correlate that yet, for sure.
Most of the things are coming off the GPU anyway, but there are instances it goes to storage. That's where we got to show that importance. And the way we see Dave, myself, work, and Mike Oglesby is doing a fantastic job building a bunch of demos, and he's doing some of the research work. Again, apart from solution, something we as a team we're doing in the background is we are looking something what the industry is doing. We wanted to make sure that we are prepared. I would say we don't have to do much with our data management layer. We already have everything. It's a matter of wrapping the solution around the technology, and we got to keep doing it.
Yeah, making sure customers understand how to use it to maximum effect. We have a lot of NetApp technologies that seem to become relevant again every couple of years as some other new computing technology emerges. And all of a sudden, the things we've been doing forever, like snapshots and clone, make a lot of sense again. But we're talking about new user bases who aren't familiar with these technologies and don't really understand how to leverage it. So that's a lot of the work we're doing, is trying to really marry the things that the industry is doing with the capabilities we have to offer. I'll say it's definitely a challenge. Like Bobby said, these things change very rapidly. We're trying to look ahead to where things are going to be. And sometimes when we get there, they never arrived because somebody found a different way. I'll throw out the example of LLM checkpointing. This was one of the biggest pain points in training a large language model. It takes a very long time, and in order to protect the process, you want to take checkpoints at various intervals so that if there's a failure or something, you don't have to go back and start over. Effectively, a checkpoint of an LLM training job is a large sequential write of the memory contents of every GPU in the cluster that's involved in the training operation. This can scale up into the terabytes worth of data that has to get written down as fast as possible. And everybody focused on it really hard. And even a public benchmark added checkpoint to their workload options. And by the time they did the development work and actually reached the point of checkpointing, the industry has found ways to do asynchronous checkpointing, and it's not nearly as much of a pain point as it was even 3 or 6 months ago. The new generation who are thinking of new ways to think about these things and new ways to implement these things is really pushing the limits.
Yep, absolutely. So if I wanted to find more information about the things you're working on, Bobby, where would be the best place to look for relevant Cisco FlexPod use cases and information there?
We do have a massive library for all the CVDs, the NVAs and TRs. A simple example, if you Google FlexPod CVDs, you get a landing page and you can find all the solutions out there, including AI.
Have you trained a model on those yet?
It's a good question. We are working on a bunch of things under the covers, and we wanted to make sure that let's bring a surprise to the team. The same thing what we did at Cisco Live, right? We didn't tell anyone, okay,
sorry, I've ruined the surprise. My bad. Dave, what about you? Where would you find stuff that you're working on?
Well, the latest generation of the SuperPod and NCP reference architectures are up on NetApp.com. That's NVA 1175 for SuperPod and NVA 1182 for NCP. There are going to be a couple more updates to those coming. And then we do have a great AI solutions landing page on the docs.netapp.com site. The documents that I'm working on will be linked into there, but that's also where a lot of our other content is around the other inferencing and other solutions that we're offering.
Bobby, did you move your camera so you could flex your badges?
I see the badge. Maybe I can show.
That's a pretty good. That's a pretty good trophy.
By the way, look at all these conferences I've been to. Look at this.
Yeah.
Yeah. Now you can say the whole thing. There you go.
Awesome. All right, well, I'm sure we'll see you at Insight in some capacity. I'm sure there'll be surprises there. I'm sure there'll be lots of good content. Again, if we want to reach Dave, it's Arnette at netapp.com. And Bobby, how do we reach you again?
It's Oomen at netapp.com, OOMMEN. My family decided to put too many repeating letters there. I don't know why.
I mean, it works. It's symmetry. Except for the end. There's no symmetry at the end there.
Yeah, I wish they did last two letters also repeating, right? 2 E's and 2 M's.
That would have been good. All right. Well, again, thanks for joining me, talking to us about all the stuff you're working on with FlexPod and SuperPod and NVIDIA and all that good stuff. Dave and Bobby, thanks. And we'll have you on again sometime soon.
All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet at NetApp. As always, if you'd like to subscribe, find us on iTunes, Spotify, Google Play, iHeartRadio, SoundCloud, Stitcher, or via TechOnTapPodcast.com. If you like the show today, leave us a review.
On behalf of the entire Tech on Tap podcast team, I'd like to thank Dave Arnette and Bobby Oomen for joining us today. As always, thanks for listening.
Oh, yeah.
Is it just me that's getting off on this?
Oh, yeah.